In today's class, we'll be looking at laws of the algebra of logical statements. And in today's video, we'll be looking at 8 different laws that we have. Now, these laws are related to what we call axioms. Okay, in which case we have the first one, which is the commutative law. The commutative law. Okay, now for each of these laws or axioms, it is such that we are using the idea of sets. Okay, now for this commutative law states that what for the first condition in commutative law we have P and Q equals Q and P. That's the first condition. Then also we also have P or Q equals what Q or P, in which case, so it means that what the solution of this one will be the same thing as this, the solution of this will be the same thing as what this. Now using intersection and union, if I say P intersection Q, the solution is the same thing as what Q intersection P. The same thing if I say P union Q, is the same thing as what Q union P. But this is not sets, this is logic reasoning. So that I'm just trying to use the idea so you can get what I'm trying to say. Okay, so then number 2 we have the associative law. Associative law. Okay, so in which case for our associative law, what do we have? We have was for the first one P and Q and R to be equals to what P and Q and R. Okay, the same thing for P or Q or R equals what equals P or Q, or R. However you arrange it, you get the same answer. Number 3 we have the distributive law. We have the distributive law, in which case we are going to have it as what for the first one we have P and Q or R to be equals what P and Q or P and R. Okay, so for number 2 we have for P or Q and R to be equals what P or Q and what P or R. Okay, so for number 4 we have the law of absorption. The laws of absorption. Okay, I believe this is the first time some of us is hearing this law. In which case, what does it state? It means that what for the first one we have P or P and Q equals P. Second one states that what P or P and Q equals what P. Now let me use that of set to explain. If I say what's P union Q, I'm going to get like the inverse set. If I now find intersection of P as a set and the inverse set, I'll get P back. You can try it out. The same thing also, if I find intersection of P and Q, I will have what is common to P and Q only. Okay, then if I now find the union with P, everything in P is what I'm going to get back, because the intersection between P and Q is finite. Okay, it's finite. Then the union between this answer and P would be what P. Okay, so then for number 5 we have the independent law. The idempotent law. Okay, so in which case what do we have? For the idempotent law we have what the first one to be what P and P to be equals to P, and for the second one we have it to be what to be P or P to be what P. That is the intersection between P and itself is P. The same thing with its union. Number 6, that's what we call the idempotent law. Okay, then number 6 we have what the Morgan's law. The Morgan's law. In which case, what do we have here? For the first law, we have it as what? Not P and Q will be equals to what? Not P or not what? Q. Not P and Q equals what? Not P or not Q. For sets, we are going to have something like P intersection Q prime to be equals to what? P prime union what? Q prime. So this is similar to what we have here. So in this case, the prime here is representing the what? Not here. Okay. So this is for sets. Okay. Then number 7, we have what? We have the law of contrapositivity. Laws of what? Contrapositivity. Okay, this law states that what? P condition Q, this is P if then Q equals what? Not P, not Q, if then what? Not P. So if I find the conditional statement of P and Q is the same thing as what? The not conditional statement, to the not Q, like that, so it's the same thing. Just putting not for both of them is the same thing as not putting not at all, in that case. Then number 8, which is the last one. Okay, so we call this law of complementation. Laws of complementation. Okay, so where we have the first one to be what? P and not P will give us false. Okay, so for the second part of this one, let me call that B. P or not P will give us what? True. Okay, so if I find not P, I'm going to have Q, isn't it? Not P will give me Q. So P and Q will give me what? Will give me false. Because when is this said to be true? It's said to be true when both P and Q are what? Are true. But I have P and Q because this is not P, and not P here is what? Not P here is what? Is Q. Then for this is the same thing as that. Then for the second one, which is C, not F is what? True. And for D, not T is what? Not T is F. Finally, E, we have what? Not P equals what? Equals P. Just as what in set P prime or prime is what? Is P. So these are the laws that we have in algebra about logical statements: the commutative law, the associative law, the distributive law, laws of absorption, independent law, De Morgan's law, law of contrapositivity, and what? Laws of what? Complementation. So do want to go through the video again if you don't understand, to get a better understanding on it.